What if the future of artificial intelligence doesn't depend on intelligence at all, but on money? We often talk about smarter models, faster chips, and groundbreaking discoveries. But behind every breakthrough in AI lies something far less glamorous: enormous capital, infrastructure, energy, supply chains, entire ecosystems built from the ground up. Before we dive into why AI may require trillions of dollars to truly survive and scale, make sure to like the video and subscribe to the channel if you enjoy deep cinematic explorations of technology's future. Now let's look beneath the surface of the AI revolution. When most people think about AI, they imagine code, algorithms, data flowing through the cloud. It feels lightweight, almost invisible. After all, you interact with AI through a screen, a chatbot, a recommendation system, a voice assistant. But AI is not just software. Behind every response is a massive physical infrastructure: warehouses filled with servers, cooling systems the size of buildings, power lines feeding enormous data centers. AI might feel digital, but it runs on steel, silicon, and electricity. And none of that is cheap. Training a modern AI model isn't like running a normal computer program. It requires thousands of powerful chips working continuously for weeks or even months. The electricity alone can cost millions of dollars. The hardware costs far more. And it doesn't stop at one model. Companies constantly retrain, refine, and expand their systems. Every improvement demands more computation. Larger models require more memory. More memory requires more infrastructure. The ambition to build smarter AI is directly tied to the willingness to spend unprecedented amounts of money. In the past, industrial revolutions were powered by factories and railroads. Today, the backbone of AI is the data center. These facilities consume enormous amounts of energy and water for cooling. They require land, construction, networking equipment, and constant maintenance. Entire regions are being redesigned to accommodate AI infrastructure. Building and maintaining these digital factories costs billions, and scaling them globally pushes that figure into the trillions over time. AI is not just a technological revolution, it is an industrial one. Every AI model runs on electricity. As models grow larger and more widely used, energy demand grows with them. Some estimates suggest that advanced AI systems could require energy levels comparable to small nations. This creates pressure on power grids and accelerates the need for new energy generation, whether renewable, nuclear, or otherwise. Investing in AI is not just investing in software. It is investing in energy production at massive scale. Without energy, intelligence goes dark. AI is not developing in isolation. It is unfolding within a global race. Governments see AI as strategic infrastructure. Companies see it as competitive advantage. This competition fuels spending. Nations invest in chip manufacturing, supply chains, and domestic AI development. Companies pour capital into research labs and hardware procurement. The numbers escalate quickly. When every major economy views AI as essential, spending doesn't stay in the billions. It climbs toward the trillions. AI does not stand still. A breakthrough today becomes outdated tomorrow. Staying at the frontier requires constant reinvestment. New chips must be developed. Older hardware must be replaced. Software must evolve. Talent must be recruited and retained. Survival in AI is not about a one-time breakthrough. It is about sustained, long-term capital commitment. When we say AI needs trillions of dollars to survive, we don't mean it will disappear without funding overnight. Smaller models and applications will continue to exist. But frontier AI, the kind that pushes boundaries and reshapes industries, depends on relentless investment. Without large-scale funding, progress slows. Innovation fragments, infrastructure decays. The future of advanced AI is not powered by ideas alone. It is powered by resources. Artificial intelligence feels futuristic and abstract, but its foundation is deeply physical and profoundly expensive. Chips, data centers, energy, talent, infrastructure. The dream of smarter machines rests on trillions of dollars in real-world investment. The question isn't just whether we can build more intelligent systems. It's whether we're willing and able to sustain the cost. If you found this exploration insightful, don't forget to like the video and subscribe to the channel. The future of AI isn't just about code. It's about the forces shaping the world behind the code. And understanding those forces is how we stay ahead.